Welcome to the lesson on biomass energy. In this lesson, we will provide you with an overview of biomass energy, including its sources, conversion methods, and its role as a sustainable alternative to fossil fuels. Let us look at our lesson objectives. By the end of this lesson, you will be able to describe biomass energy. Next, you will be able to list the sources of biomass for energy production. Subsequently, you will be able to describe methods for conversion of biomass into useful energy. Then, you will be able to list the advantages of biomass energy. Finally, you will be able to explain how biomass energy influences BEV manufacturing. What is biomass energy? Biomass energy is derived from organic matter, such as wood, plants, and agricultural waste. Biomass energy can generate electricity, heat, and transportation fuels. Biomass energy is a renewable energy source that can be replenished naturally. Biomass is created when plants use sunlight to convert carbon dioxide and water into carbohydrates. When biomass is burned, the energy stored in the plant is released. Biomass, comprising recently living organic materials like food waste, crop residues, sewage, forest debris, microalgae, and cultivated crops, serves as a versatile energy source. The processing of biomass for energy generation yields valuable byproducts, known as bioproducts, which can substitute for petroleum-derived industrial materials. Let's look at the historical context of biomass energy. Biomass has been an energy source for as long as humans have existed. In the early days of human history, biomass was the primary energy source for cooking, heating, and lighting. The first modern application of biomass energy was in biomass-powered steam engines. In the 19th century, biomass was used to power steam engines in factories and locomotives. The conversion of biomass into liquid fuels, such as bioethanol and biodiesel, gained momentum in the 20th century. Bioethanol is made from corn and other starchy crops, while biodiesel is made from vegetable oils and animal fats. How does biomass work? Biomass energy is generated by converting organic materials like wood, agricultural waste, or animal manure into usable energy through processes such as direct combustion, chemical conversion, thermochemical conversion, and biological fermentation. These methods transform the stored chemical energy in organic matter into heat, electricity, or fuel by breaking down the biomass using methods like burning, chemical processing, or microorganism-driven fermentation. The result is a renewable energy source that can replace fossil fuels while utilizing waste materials that would otherwise be discarded. What are the sources of biomass? The sources of biomass include wood, microalgae, animal manure, human sewage, dedicated crops, agricultural residues, which are waste crops, vegetable or animal oils and fats, and trash or garbage. One of the greatest advantages of using biomass for energy is the abundant sources available, many of which would otherwise be wasted. These resources may be used either directly as fuel or converted to other products known as feedstocks, which serve as principal inputs for various industrial processes. Rather than discarding these sources as waste, they can be efficiently converted to meet other needs, reducing reliance on less environmentally friendly energy and raw material sources. Biomass remains a crucial energy source, particularly in underdeveloped and developing countries, where it serves as the primary means of heating and cooking. In recent years, modern technological approaches have transformed biomass into a key energy resource and productive byproduct, especially in developed nations' industrial and transportation sectors. The U.S. stands out in this landscape, boasting a net surplus of biomass. According to U.S. Energy Information Administration, abbreviated as EIA, in 2023, the country exported approximately 8.6 million tons of wood fuel pellets, demonstrating the growing significance and economic potential of biomass energy production. What are the methods of biomass energy conversion? The various methods to transform biomass into usable energy forms are direct combustion, chemical conversion, thermochemical conversion, and biological conversion. Let's look at each one of these methods. Direct combustion, or burning, is the most common method for converting biomass to useful energy, a technique humanity has employed throughout its history. This straightforward approach involves directly burning biomass materials to generate heat or electricity. Chemical conversion represents another important method of biomass energy production. By processing vegetable oils, animal fats, and greases, manufacturers create fatty acid methyl esters, abbreviated as FAME, which are used to produce biodiesel, an alternative fuel source. Thermochemical conversion involves heating biomass feedstock materials in pressurized vessels called gasifiers at high temperatures. This method is complex and has several variations, with differences arising from the temperatures used and the amounts of oxygen, hydrogen, steam, and other raw materials supplied during the conversion process. Biological conversion, a method practiced by humans for much of its history, utilizes fermentation to produce ethanol and biogas. Ethanol has become a common vehicle fuel, while biogas can be generated in diverse settings such as sewage treatment plants, dairy and livestock operations, and solid waste landfills. There are several advantages of biomass energy production. Let's look at some of them. Biomass energy production benefits from many versatile and renewable sources that can be readily utilized. These diverse sources provide flexibility and sustainability in energy generation. Biomass offers a significant alternative to petroleum, extending beyond energy production to create useful byproducts such as plastics, lubricants, and industrial chemicals. This versatility helps reduce dependence on fossil fuel-derived materials. Biomass energy can be nearly carbon neutral because the carbon dioxide, CO2, released during its combustion is roughly equal to the CO2 absorbed by the plants during their growth. Let's look at the future potential of biomass. Humans and nature constantly produce abundant waste, with a very large portion of this waste readily available as an energy resource that may be expanded regionally. This continuous generation of organic waste presents an ongoing opportunity for biomass energy production. Biomass offers a significant advantage in its well-understood chemistry and established industrial base, coupled with a long history of human use. These characteristics provide a solid foundation for further development and implementation of biomass technologies. Biomass offers an exciting alternative to petroleum. Just like oil, it can be used to create fuels and useful chemicals. By applying similar industrial techniques, biomass shows promise as a sustainable resource that can replace traditional fossil fuels. It's a flexible option that could help us move toward cleaner energy production. Let's look at how biomass energy influences BEV manufacturing. Biomass energy can power BEV factories with cleaner electricity, reducing pollution from making BEVs. Using biomass instead of fossil fuels helps lower the carbon emissions during the BEV manufacturing process. Biomass comes from renewable materials like plants and waste, supporting a greener supply chain for BEVs. Let us now look at our lesson summary on biomass energy. Biomass energy is derived from organic materials like wood, plants, agricultural waste, and animal manure. It is renewable and can be replenished naturally, utilizing waste products that would otherwise be discarded. Common sources include crop residues, microalgae, trash, and sewage. Biomass is converted into usable energy through direct combustion, chemical conversion, thermochemical conversion, and biological fermentation. These processes produce heat, electricity, and fuels like biodiesel and ethanol. Biomass reduces waste, lowers reliance on fossil fuels, and produces byproducts like bioplastics and industrial chemicals. It supports sustainability with abundant and diverse sources, including renewable feedstocks. Biomass energy supports cleaner and eco-friendly BEV manufacturing by reducing emissions and using renewable resources. Thank you.